Welcome back. In this lesson, we will learn about electrostatics. It's about charges at rest or stationary charges. So, electrostatics is the study of charges at rest. So you learn about when the charges are stationary, their behavior, their interaction and everything. But before we do that, we need to know what is a charge. Now, talking about charge, it's a basic or fundamental property of matter. Like mass, charge too is a fundamental property of particles. So when we talk about particles like protons, electrons and neutrons and other particles, there are different things which characterize them. And one of them is charge, the other one is mass, then we have spin, symmetry, there are many things. So for fundamental particles, charge is a property. So it is not an entity. It is a property. So we will get to know the characteristics or the properties of charges. And you must remember, charges always exist as a characteristic of a particle. So let us see what are the different characteristics associated with charges. So, properties of charges. The first one, unlike mass, charge comes in two different kinds. Mass is always positive. You never get negative mass. But charge comes in two different kinds. You may get positive charge and you may also get negative charge. For example, a proton is positively charged, an electron is negatively charged. So that's the first property. The second property is the additive nature of the charges. And means if there are several charges, both positive and negative charges on a body, if you want to find out the net charge of that body, you need to add those charges together. You need to take the signs into consideration. So the net charge of a body is the algebraic sum of all charges on that body. The net charge of a body is the algebraic sum of all the charges on the body. The net sum or the net charge of a body is the algebraic sum of all charges on that body. It means you have to add up all the bodies, all the charges together, you will get the total charge of the body. So suppose you get equal amounts of positive and negative charges on a body, the body becomes neutral. You call it a neutral body because there are equal number of positive and negative charges. The third property is the conservation of charges. Charges are conserved. In all kinds of interactions, the charges are conserved. You can never destroy charges, you can never create charges. For an isolated system, the total charge is conserved. So just like conservation of mass, conservation of energy, you have conservation of charge as well as one of the basic laws of nature, conservation of charges. So this conservative nature of charge will help us to actually interpret many of the interactions, particularly in nuclear and atomic physics. So that is the third property, conservation of the charges. Now, the fourth property is called quantization of charge. It's a little bit strange. You may not be familiar with this particular one. What does it mean by quantization of charge? The basic idea is that the charges you find in nature are always a multiple of a basic unit. For example, this basic unit of charge is in magnitude equal to the charge of an electron. So, if you get any object, the charge on that body will be n times the charge of an electron. You cannot get, for example, if you say the charge of an electron is small e, then you will never get a body with a charge e upon 2, half the e value or quarter the e value. So e value is equal to 1.6 times 10 to the power minus 19 coulomb. That means you will never get a charge of 1 times 10 to the power minus 19 coulomb for any object in this universe. Either you can get 1.6 into 10 to the power minus 19, or you can get 3.2 times 10 to the power minus 19, or you can get 4.8 times 10 to the power minus 19 coulomb, and so forth. It will be always the multiple of the charge of the electron. Of course, the magnitude is taken, can be positive or negative, but the magnitude would be the same as the magnitude of the charge of an electron. So, for a proton, the charge is plus 1.6 times 10 to the power minus 19 coulomb. For an electron, it is minus 1.6 times 10 to the power minus 19 coulomb. The coulomb is usually coulomb is usually written as capital C, which is the unit of charge. It's called coulomb, COULOMB, that is the SI unit of charge. Now, for subatomic particles like electron, protons, and neutrons, electrons will have minus 1.6 times 10 to the power minus 19 coulomb, which are negatively charged. Protons, which are positively charged, will have an equal charge of 1.6 times 10 to the power minus 19 coulomb, but that is positive. And a neutron will have zero charge. It does not have any, it's a chargeless or it's a neutral particle. So, this is the basics of electrostatics. We will continue further on a little bit more about the quantization, and then we will see the interaction of charged particles. And always remember, particles are associated with, or rather charges are associated with particle. Charges as such do not have an existence because it's a character. It is not an entity. Thank you. Thank you very much for being with me for this short lesson. Thank you.